Hello ladies and gentlemen. Today's class we're going over pure substances. We went over those before, and the new information is going to be physical and chemical properties of matter. So these are the two starters that should be in your notebooks. What is a pure substance? You should already know that from the previous class. And what are the physical and chemical properties of matter? You should at least make a guess on these. You can look up the answer later in the book. If you haven't already, you can go to mr.nacru.net in order to get the classroom information. You're probably here already as you're listening to this video. When you're at that site, you can download any of the materials and work on it from home. If you're unable to get to the website from the school, it's because they currently have the student access blocked, although I'm working with the IT department to get this unblocked. So today's objective, we are going to be classifying different substances. So whenever you're doing through this period, or if you want to work on this independently and do your own research, we're looking to classify all the different substances that we come into contact with. This is something chemists do so that we can look at the properties and other things that help us deal with everyday life. Again, as a reminder, matter is the big word for the week. Anything that has mass and takes up space. So, pure substances. The second part of your Cornell notes below the vocabulary should have something that starts off at the top with matter and moves down as a flow chart. So today, the literary activity we're going to be working on is how to read and follow a flow chart. So, if you start at matter, and you look just below matter, there's a question. The question asks, can the substance be separated by physical means? If it cannot be separated by physical means, this means it's a pure substance. If you bring your finger down to where it says pure substances and look at the question below there, it asks, can the substance be separated by chemical means? If it cannot be separated by chemical means, that means it's an element. An element is a substance that is made entirely from one type of atom. This would be something along the lines of anything on the periodic table all by itself. Now, if it's on the periodic table of elements, but there's also another piece of, or another atom from the periodic table of elements, then we go over to compounds. So these things can be separated by chemical means. They can't be separated by physical means, but they can be separated by physical means, let me say that again. Compounds can't be separated by physical means, but they can be separated by chemical means. In order to do this, you take two or more elements that are bonded together, and through different chemical processes, whether it's having it react with other items or using flammability as a way to cause a chemical reaction, you are separating those bonded elements or having them attach themselves to new elements. Now, if a substance can be separated by physical means, so if you imagine a piece of granite, granite can be separated by physical means because if you started hitting it with a hammer, you'd see the different pieces of that granite, the little individual minerals and rocks, you'd see that they were able to come apart from each other. There are two types of mixtures. There are homogeneous mixtures and heterogeneous mixtures. The first mixture we're going to focus on is the homogeneous mixtures. Homogeneous mixtures are typically solutions where the pieces have become indistinguishable from each other. You'll see that the question there it asks to separate into homogeneous or heterogeneous. It asks, is it uniform in composition? So an example of something that's uniform in composition would be salt water. Salt water is a homogeneous mixture. Now, a heterogeneous mixture is a mixture that is not uniform in composition. For example, the granite that we talked about earlier. Granite itself is heterogeneous. If you need more help on either of these two vocabulary words, please look it up in the book. There's a great explanation in there as part of the readings. So the assignment that we went through for the day, and that you'll do on your own if you weren't in class, is you're going to go ahead and classify these substances. To help you along with this, I'll give you some clues. The first one we have here is air. When I say air, I don't mean oxygen. I mean all the components of air. So if you think about that, that means you have oxygen, you have carbon dioxide, you have water vapor, and all the other elements that make up the air. Now these elements are not bonded together. So if they're not bonded together, does that mean that they are a physical and therefore a mixture, or does this mean that they can't be separated physically and therefore a pure substance? Think about that for a moment. They're not bonded together. Can they be separated physically? An example I like to give people to get an idea of what might work is if you imagine wearing a gas mask that is filtering out parts of the air. Now the next step you're going to do is try to decide if it's a homogeneous or heterogeneous mixture. I could go either way on this. If you think about the air in a confined space such as a room, it's possibly more homogeneous. But if you think about the worldwide, it's probably heterogeneous. If you think about just in LA, the smog compared to up here in Southern Oregon, have a totally different mixture of air based on the particles that are found in the pollution. The next item you're going to identify is lithosphere. You should remember this from the section on rocks, from the rock cycle. What is in the lithosphere? Would this be considered something that's homogeneous, or would this be something that's considered that you can separate by physical means or chemical means? Now, I would have to say that you're going to probably choose that it's a mixture, and from the mixture, are you going to choose homogeneous, uniform in composition, or heterogeneous, pieces that you can actually see as separate? Here's a picture of stew. This is the next substance. Is this a mixture? If it is it heterogeneous or homogeneous? Here's some chocolate. This is a tough one. I have an answer for people who want to ask me about this, but if you're going to go try it on your own, I'm going to accept almost any answer as long as you can explain your reasoning. Nitrogen. If you take a glance at a periodic table, you'll get the answer to this one really quickly. Magnesium. The picture here actually gives you the clue. Carbon dioxide. Carbon dioxide. Those look like two elements bonded together. I wonder if that's a clue. Carbon. So those are the different elements, the substances that you should be looking up and writing just below, in the blank space below the last bubble for each of the items in the flowchart. You should not be writing this stuff down on the backside of the paper. The backside of the Cornell notes is reserved for the next lesson. For closure, I'd like you to take a moment and think about a couple of differences between mixtures and compounds, or elements, and then write those differences on your flowchart. So next time, we're going to be looking at properties of matter. We'll be looking at the density, state, reactivity, and flammability.